morning. Once again I welcome you all to the foundation engineering course, and we are actually discussing on stability analysis of earth retaining wall. And for that, before going for stability analysis, whatever necessary things, essential things are actually earth pressure, different types of earth pressure like earth pressure at rest, earth pressure at active condition, earth pressure at passive condition, all those things we have done, and we have taken some problem to calculate earth pressure for different condition. Also, I have taken some problem for stability analysis. Now, for stability analysis means what? Actually, we have to find out factor of safety against different failure modes like factor of safety against sliding, factor of safety against overturning, factor of safety against bearing capacity failure, etc. And I have taken one problem in my previous lecture, and once again I will take one more problem, and where actually I am taking little problem of involvement of everything, but exam generally you expect little simpler. But I will highlight where actually you can simplify, but I am taking the problem little complicated mainly because I want to show the application of everything. Okay. So, let me start with the second problem of stability analysis. It is the problem is like this, there is a cantilever retaining wall, and this cantilever retaining wall is your you can see that it is a concrete part, and these are concrete part, and this is having a backfill, and that backfill is again inclined. So, this angle is not shown, suppose it is 10 degrees slope, and generally whatever earth pressure theories we have learned, that is actually for horizontal backfill and particularly Rankine, and that is simple which we use commonly. But however, we have also discussed if there is a backfill is sloped, how to handle this, how to modify the Rankine's theory, that also we have discussed. And now, this problem actually you can see that this type of problem, as I have told you before yesterday, actually I have taken a problem something like this, and the back was vertical. Okay. So, whatever height of the wall, this is the wall height, but when this type of slope backfill, then in that case actually what we do, from the edge of the end of the vertical wall, actually we draw the vertical line from here, and you can see it is it is meeting the backfill soil surface at here. So, that means I will imagine now the wall from here to here, this is the wall height, this is the wall height I will imagine. So, while discussing the problem in the previous lecture, if the wall was something like this and something like this, then also have told that if there is a backfill soil here like this, then if I extend you have to imagine the wall equal to this, this is the wall, I have to imagine this is the wall, and if it is a backfill, then I have to go up to this, and you have to imagine this as a wall. So, and while doing this, then this soil weight coming onto the this retaining wall. So, because of that, when I will consider this wall, actually initially wall height is, suppose this is given 6 meter and this is 7.7. So, it is 6.7 from here to here, it is 6.7, but for the calculation purpose, earth pressure calculation purpose, I will find out actual modified or imaginary height, which will be this height to be calculated. Since this angle is known, this length is known, so I can find out by tan formula this height. So, after getting this height, then I have to find out, imagining this as a wall, and I have to find out earth pressure first. And when I will find out the earth pressure, I will have to imagine that earth pressure are inclined parallel to this surface, and so thrust will be something like this. So, for calculating this, again I have to follow step by step procedure, and which I will try to show you the detailed calculation. And here actually what are the things are not given, let me see. Unit weight is given 18 here, and angle of internal friction is given 30 degrees, I think I have taken 30 degrees and the coefficient of base friction 0.5, allowable pressure for foundation is 200, all those things, and concrete unit weight is not given. We can imagine gamma c equal to 24 kilonewton per meter cube. This is the only thing we can additionally assume. Otherwise, this is the problem, and so this problem, let me take a fresh page and then let us try to do. So, problem was something like this. You have a wall and this is little sloped here and this side vertical and this is something like this. So, and this is again 10 degrees, and if I join from here, and this is actually this dimension now I have to put, this is 0.7, this is 0.7 and this is 2.6. And you can see that this is actually 0.5, this is 0.5. That means, if I draw a vertical line, so this small portion that will be 0.2. Okay. So, this is the wall. So, this distance, that means I can find out this will be nothing but this distance is from here to here 2.6. So, this distance will 2.6, this will be 2.6 tan 10 degrees and whatever it comes, and so that will be equal to, that means we had that means wall height, actual effective wall height H e, suppose effective wall height, it will 6 plus this is 6 actually and this is 0.7. So, 6 plus 0.7 plus 2.6 tan 10 degrees and that gives you 7.16 meter. So, instead of 6.7 I will take 7.16 meter and your Ka will be equal to cos beta minus under root cos square beta minus cos square phi divided by cos beta plus under root cos square beta minus cos square phi, and here phi equal to 30 degrees and beta equal to 10 degrees, and if I put this value comes actually approximately 0.32. Now, for earth pressure calculation, actually you have to find out the thrust. So, this will be acting somewhere something like this thrust, and this height will be suppose your 7.16 by 3. So, it will be there. So, what will be the pressure, how to find out, and of course, 7.16 pressure at this point will be pressure at this point. Suppose if I imagine a pressure diagram will be something like this. And so, this pressure diagram will be gamma means 18 multiplied by H actually 7.16 multiplied by Ka means 0.32. So, this will be whatever it comes, this will be so, this will be pressure, and now I can, if I can find out P A. So, this is suppose intensity pressure P at this point. So, P A, this is P A suppose, then this will be half multiplied by again the entire thing 18 multiplied by 7.16 multiplied by 0.32 multiplied by once again 18 once again 7.16, okay, because this height. So, this is base multiplied by half multiplied by this is base multiplied by height. So, this if you calculate it comes around 147.64 kilonewton. And then I can imagine this inclined force I can imagine is acting vertically. So, that I can say as P active vertical, and I can consider around horizontal, that is P active horizontal. So, if I do that, so this will be, that means it will be component of cos 10 degrees. So, P A V will be coming, P A V will be P A sin 10 degrees and P A H equal to P A cos 10 degrees. So, this will be 25.64 and this will be 145.4. These are all kilonewton. So, this is actually earth pressure calculation. Now, in addition to that, what are the other calculation I have to do? I have to do that for stability analysis, you have to calculate the gravity load, and gravity load, that means you can see that now I have imagined this is the wall. So, that means this soil will be there, this soil will be there, this concrete will be there. And another thing I have missed actually, there is a, this side there was a embedment, some height actually, and as I have told you that to be in Shepard side, this can be ignored, that is this side will be passive and this side will be active, and if I ignore the passive pressure, generally we will be in Shepard side. So, I am trying, for the time being I am ignoring. So, if I do that, then at least what are the things you have to calculate? I have to calculate different part, this suppose 1, this suppose 2, this suppose 3, this suppose 4 and this suppose 5. So, there are 5 component of gravity weight, and so 1 will be for 1, suppose W 1 will be equal to nothing but 0.5 multiplied by 6 multiplied by 1 multiplied by 24, and that will be equal to 81.08 kilonewton, and it will be if I imagine that with if I consider how far from this point A, and that distance will be your this distance will be your 0.7 plus 0.9 plus 0.9 plus 0.25. So, this D 1 or lever arm actually distance, lever arm suppose x 1, suppose if I say that will 0.7 plus 0.2 plus 0.25. So, this will be equal to 1.15. So, similarly 2, that means W 2 if I do, that will be nothing but half multiplied by 0.2 multiplied by 6 multiplied by 24, that gives you approximately 11.75 kilonewton, and that distance will be suppose x 2, that will be 0.7 plus this will be 2/3 of 2/3 of 0.3 0.2, 2/3 of 0.2. So, that will be your 0.833, 0.833. Now, component 3, that means this entire this one. So, this will be W 3 suppose, then it will be 0.7 multiplied by 4 multiplied by 1 multiplied by 24, that gives you weight actually 131.6 kilonewton, and its lever arm, it is acting at the midpoint. So, it will be x 3 will be equal to, since it is a 4 meter. So, it will be 4 by 2 equal 2 meter. Then fourth part actually this soil. So, this will be, that is nothing but W 4 will be equal to your 6 multiplied by 2.6 multiplied by 1 multiplied by 18. So, that will give you 18. So, that will be equal to 2.72, no, to 280.280 8, and suppose x 4 will be equal to, you can see 1.3 plus 0.7 plus 0.7 plus half of this 1.3. So, that will be equal to 2.7, and suppose x 5 component 5, that is suppose W 4, and that W 5, that will be equal to half multiplied by 2.6 tan 10 degrees multiplied by 2.6, and that will be area multiplied by 18. So, that gives you your 10.71, and your lever arm will become, suppose x 5 lever arm will become, this will be 2/3 of 2.6, 2/3 of 2.6 plus 0.7 plus 0.7. So, that will give you approximately 3.13. So, now all force calculation is done, and now we have to, what you have to do? We have to calculate total vertical force, that means total V, suppose, or P vertical, total vertical force, suppose, that will be W 1, W 2, W 1 plus W 2 plus W 3 plus W 4 plus W 5 plus P A V, and if I do that, that will become 467.55. And then we can now, after that I can do one by one calculation, and what I can do, this is actually your first of all, first factor of safety against overturning, factor of safety against overturning, that will be equal to your m r by m naught, m r by m naught. So, that will be m r is what? Wall weight. If the wall is something like this, so you can see, because of the 1, 2, 3, 4, 5, because of the all the weights actually creating restoring moment, resisting moment, and only P h is giving you moment is this direction. So, for overturning. So, overturning M r will be all forces W 1 H 1, W 1 X 1 plus W 2 X 2 plus W 3 X 3 plus W 4 X 4 plus W 5 X 5 plus P A V multiplied by P A V multiplied by, that was at a distance here actually. So, it will be 4 divided by M resistance will be what? P A H multiplied by because 7.16 by 3. So, if I do that, then it will come factor of safety against overturning, it will come something 3.22, and it is quite big value, its expected value is 1.5. So, greater than that, so it will be okay generally. Similarly, factor of safety against sliding, factor of safety against sliding, that will be equal to resistance divided by disturbing horizontal force. So, fixed resistance, or I can say F r divided by F. So, F r will be equal to friction is given 0.5 multiplied by vertical force, that is actually 467.55, and that is actually below the wall, because of total vertical load multiplied by frictional coefficient, that is actually resistance, whereas your horizontal force is actually will be by upward, that horizontal force which you already P A H we have calculated, that was actually your PAH was 145.4. So, this gives you a factor of safety will be equal to will give you 1.6. Now, that is also greater than 1.5 and hence it is okay. Okay. So, now I have to see the factor of safety against bearing capacity, and for that I will just take another new page, and for that actually as I have told you that the wall is something like this. So, different forces are acting. Finally, the point of application of the resultant force may be somewhere here. If I take vertical and horizontal and take moment with respect to this, then I can find out that point of application of this distance, the actual x bar I can find out. How to find out actually? X bar multiplied by V will be equal to m r minus m naught. Okay. And so, if I do this, then your x bar will be equal to m r minus m naught divided by V, and that m r already I have told you that W 1 x 1 plus W 2 x 2 plus W 3 x 3 plus W 4 x 4 plus W 5 x 5 plus P A V multiplied by that distance that is suppose x 6, and m r will be minus m r will be equal to how much? P h multiplied by h by 3, and if I put all those values and this finally the x bar will come approximately 1.65 meter. X bar means ultimately the point of application of this load on the base resultant force where it is acting. So, if I draw the base of the footing now, suppose this is 4 meter, this is sub 1 meter and this is 4 meter. So, this is 2 meter. So, it is acting at 1.65 somewhere here, this is 2. So, 1.6. So, this is actually E, that means force is acting at eccentricity, and that eccentricity can be calculated, E can be calculated equal to B by 2 minus x bar, and that is equal to 2 minus 1.65. So, that is actually equal to 0.35, and this is also in while doing bearing capacity we have mentioned that to satisfy the no tension in the foundation, we have this has to be less than B by 6, and that is also satisfied. Now, after getting this, you know that when there is eccentric vertical load is acting eccentrically, then there will be a moment which will be equal to V multiplied by E. So, that means in this foundation, suppose in this rectangular area, there is a vertical force and there is a moment. Then to find out the pressure, actually we use a typical formula, either sigma equal to actually sigma equal to V by A plus minus m y by I, and this rectangular area I if you substitute, y if you substitute, moment if you substitute, then this formula can be also simplified as sig V by A and 1 plus minus 6 E by B. So, this actually if you substitute all those things in terms of B and A all, and then eccentricity, then this expression also can be modified to in this form. And now, if we know the V actually value of V I know, that is actually your already I have shown V was 467.55, and area actually is nothing but 4 meter by 1 meter, and so this is 1 plus minus 6 multiplied by E is here 0.35 and divided by B is here your 4 meter. So, this one if I do, then equal to sigma max will be equal to coming this 1 plus this multiplied by this is coming 178.25 kilonewton per meter square. So, that is similarly I can find out sigma minimum also, and this value 178.25 kilonewton per meter square, this is the value maximum value. That means, below the footing if I draw the elevation, if the footing is like this elevation, if I do elevation, and below the footing actually pressure diagram will be something like this. So, this side is maximum and this side is minimum, and this maximum value is coming 178.25 kilonewton per meter square, and it is given that foundation pressure maximum foundation pressure is can be 200 kilonewton. So, it is less than that. So, it is also, so that means it is okay. In fact, actually we need to find out this, and whatever value is there given we have to compare. So, here it is given 200. So, if you compare, then it is coming less than that. So, that means looks like okay, but sometime it may desire that you have to give a factor of safety of 1.5 or 2 also. In that case, you have to find out that ratio of that should be 1.5 or 1.6 or 2, whatever expected. So, like that. So, these are the problem. That means, we have got we have started from so all three problems are done. So, this problem is done now. As I have mentioned that we may have to you may expect little simpler problem in the exam. What is simpler actually? So, this wall, suppose this is the wall here, and this is the wall. So, this inclination is there. Instead of that I may give we may express horizontal. In that case, your wall height will be only this much. You extend from here, and this will be wall height. So, this will be wall height will not change here. Wall height will change only when there is a level backfill. Okay. So, here wall height will be, it was 6 and it was 0.7. So, it will be wall will be 6.7. So, like that, if I do that, little simplification will be there, because your Ka calculation in that case 1 minus sin phi by 1 plus sin phi, instead of that cos beta minus under root cos square beta minus cos square phi divided by cos square beta plus under root cos square beta minus cos square phi, that was the expression. That expression will be simplified like this. And additional thing is, when there is a level backfill, your pressure was like this, and we have made two component PAV and PAH, and when this horizontal backfill, then straight we will get the PA horizontal. So, that is the only horizontal force which will create overturning moment, and also it will give you sliding. So, that cause sliding. So, this will be horizontal. So, this is the problem I have taken to show application of everything, but in the exam sometime you have to do in the less time, and then in that case you may not have this type of things, but if it is there, how to calculate, that is the procedure I have shown, that I have to use the complicated formula, a little complicated formula for Ka calculation, and after calculation of Ka I can find out Pa, and finally direction of Pa will be parallel to this backfill, and when the force is parallel to the backfill, that means it is not neither vertical nor horizontal, but you have to work with horizontal and vertical force. Then because of that you have to make two component, one horizontal and vertical, for the calculation. So, that is the way we can do it. Okay. So, with this I will close this one. Thank you.